Find the sum to n terms of the following series. Let us begin. So here we have the series that's given by 3 plus 15 plus 35 plus 63, and we have the rest of the terms. Now this particular series, this is not an arithmetic series, but that's because we do not have a fixed common difference here. However, we do notice a pattern here. If we take the second term, which is 15, and from here subtract the first term, that is 3, so that gives us 12. Next, if we consider the third term, and from it subtract the second term, that's going to give us 20. Next, we will consider the fourth term, that is 63, and from here subtract the third term, 35, that's going to give us 28. Now we observe here that 12, 20, 28, and similarly the rest of the terms, these are forming an arithmetic progression. So what we will do here, we will use the method of difference to obtain the sum to n terms. So for this, let us suppose that this series is represented by Sn. Then what is the nth term of this particular series? So we will assume that the nth term is given by Tn. That means if it is Tn, then the second last term will be denoted by Tn minus 1. Now what we'll do, we'll again consider the same sum up to n terms, but we'll start with the first term 3 and write it below 15. Then we'll consider the second term, which is 15, but write it below 35. And then we have 35 below 63 all the way up to the last term. Then we have Tn minus 1. We're going to write it below Tn and the last term. The reason what we're doing, we're going to take the difference of the two sums. Now on the left hand side, we simply have 0. We'll keep the first term as it is, that's 3. This will be added to, now 15 minus 3, so that's going to be 12. We've already talked about this. 35 minus 15, we have 20, added to 63 minus 35, so that's 28, going all the way up to the second last term. So we have Tn minus 1, and then we have minus Tn. Okay, now what we'll do, we will transpose Tn to the left hand side, so that gives us Tn equals to 3 added to. Now as we have already mentioned that 12, 20, 28, these terms are in arithmetic progression. So if they are in arithmetic progression, then we can easily find out the sum up to n terms, because we have a standard formula for it, which is given by n over 2 multiplied to 2 times the first term added to 1 minus 1 times the common difference d. Now we have to figure out what is the first term, what is the common difference, and how many terms are there. So here we have the first term that's equals to 12. The common difference d, that will be equals to 8. And here we have a total of, let's check how many terms are there. So first for Sn, we consider the first term and went all the way up to the last term, which means we excluded the first term, and by definition says Sn has got n number of terms. So excluding one of the term leaves us with n minus 1 number of terms. Now similarly for the second sum that we consider the first term all the way up to the second last term, so this also has got n minus 1 number of terms. Now subtracting n minus 1 terms from another n minus 1 terms is going to leave us with n minus 1 number of terms. So that means that is the total number of terms present in this arithmetic progression. So we can apply the formula. We have n minus 1 over 2. We use this formula for Sn, but replace n with n minus 1. This will get multiplied to 2 times the first term, that's 12, added to n minus 1. So here we have n minus 1 minus 1 times the common difference, that is 8. Okay, now let's further simplify. This is going to give us 3 added to n minus 1 over 2 multiplied to, so we have 2 times 12, that's 24, added to 8n minus 16. So that's going to give us 3 added to n minus 1 times 2 multiplied to 8 plus 8n. We can factor out that 8. So this is going to give us 3 added to 4 times n minus 1 multiplied to n plus 1. Further simplification, now it's going to give us 3 added to 4 times n squared minus 1. We have 3 plus 4n squared minus 4, which means we have 4n squared minus 1. This is going to be the nth term of the series. So we got it as 4n squared minus 1. So 4n squared minus 1 is the nth term. We can verify that this is indeed the nth term. So if we substitute n with 1, then we're going to get the first term. Substituting n with 2 gives us the second term. Substituting n with 4 gives us the fourth term. So now that we have the nth term of the series, we can find out its sum. So the sum will be defined as, now the sum up to n terms, that's defined by, take the summation of the nth term but replace the index n with k, because the k runs from 1 to n. So we have summation for k squared minus 1 with k going from 1 to n. Let's simplify the sum. We have 4 multiplied to summation k squared, where k goes from 1 to n, minus summation of 1 with k running from 1 to n. Now summation of k squared, this is simply the sum of the squares of the first n natural numbers. And we have a standard formula for it, that's given by n multiplied to n plus 1 multiplied to 2n plus 1 whole divided by 6. And then we have summation of 1. So what does it mean when we say we have summation of 1 with k running from 1 to n? This is simply 1 added to 1, and this is happening n number of terms. So that means total it will be simply 1 times n, which will be equals to n. We have n here. So let's simplify to get 2n multiplied to n plus 1 times 2n plus 1 whole divided by 3 minus n. We're going to combine this. So we will now have 3 as the common denominator. In the numerator, we're going to get 4n cubed plus 6n squared plus 2n minus 3 times n. And therefore, the final sum comes out to be 4n equals to 4n cubed plus 6n squared minus n divided by 3. So this is going to be the sum of the given series, where we have 3 plus 15 plus 35 plus 63 all the way up to n terms.